So here's what makes Proxima B seriously fascinating. It's an Earth-like planet orbiting the closest star to our sun. For the very first time in human history, we're not just daydreaming or running simulations about what another Earth might look like, we're actually seeing it. Thanks to the James Webb Space Telescope, the most powerful space observatory ever built, scientists have just captured the clearest image yet of Proxima B, orbiting Proxima Centauri, our nearest stellar neighbor. At only 4.2 light-years away, Proxima B has been a hot topic for years. It's roughly the same size as Earth and orbits in what's called the habitable zone, that sweet spot around a star where conditions could allow liquid water to exist on the surface. Up until now, all we had were numbers, estimates of its mass, how far it was, how fast it orbited. No real visuals, just data points on a spreadsheet. But today, everything changed. Webb didn't just catch faint sunlight bouncing off the planet. Instead, it detected the planet's own heat glowing in infrared light. This means we're literally seeing the planet itself, not just a distant blimp or a theory. This is huge. Proxima B isn't just a dot on a graph anymore. It's a real place with its own story. What can this image tell us about its surface, its atmosphere, its potential for life? Could this be the very first actual look at a world beyond our own that might be Earth-like? And if this is just the beginning, how many more alien worlds are out there waiting to be discovered? This isn't just a cool science milestone. It's history in the making, a genuine glimpse of another Earth right in our cosmic backyard. For the first time ever, we've seen it, not imagined, not computer-generated, but truly seen. A real image of an alien planet just over 4 light-years away. The James Webb Space Telescope has just given us the clearest look ever at Proxima B, a planet orbiting the star closest to our sun. But this isn't just another cool space photo. It's way bigger than that. For decades, astronomers have been hunting for Earth-like planets, places that might have the right ingredients to support life. Proxima B has always been one of the top contenders. It's nearby, almost Earth-sized, and sits comfortably in the habitable zone, the Goldilocks area where temperatures could allow liquid water to exist. But until now, all we had were guesses and numbers. We knew about it from subtle wobbles in its star's movement and tiny dips in brightness when the planet passed in front. But seeing it? That was impossible. Then Webb stepped in and flipped the game. Thanks to its powerful infrared eyes, the telescope blocked out the bright glare of Proxima Centauri and zoomed in on the faint signal from the planet itself. Over several weeks, Webb collected enough data to put together the sharpest image ever of Proxima B. And what it revealed? Absolutely stunning. No longer just a blurry speck, we could spot temperature differences across the planet. One side likely baked in constant daylight, the other shrouded in darkness. Even more exciting, it looks like Proxima B isn't hidden beneath thick clouds like Venus. The way its surface reflects light tells us it's rocky, Earth-like, not a gas giant or an endless ball of clouds. This isn't just a scientific victory, it's a game changer. Proxima B isn't just a mystery anymore. It's a real place with shadows, heat, and maybe even the right conditions for something more. Do we know if life's there? Not yet, but for the first time ever, we can look at that nearby star and say, we've seen its planet, and that changes everything.
All right, let's pull back and talk about the star Proxima B calls home, Proxima Centauri. This isn't just any star. It's the closest one to our sun, part of a 3-star family known as Alpha Centauri. 2 of those stars are bright enough that you can spot them in the night sky without any fancy gear. But Proxima Centauri? It's the smallest, coolest, and dimmest sibling in the bunch. You won't see Proxima Centauri with your naked eye. You need a telescope for that. But here's the kicker. It's the star with the most intriguing planet in the neighborhood. Proxima B orbits insanely close, way closer than Earth orbits the sun. It zips around its star in just 11.2 days, making a full year shorter than 2 weeks here on Earth. Now, even though Proxima Centauri is much cooler and less bright than our sun, Proxima B still sits in what scientists call the habitable zone. That's the sweet spot where a planet could get just the right amount of energy for liquid water to exist on its surface. And water is the key ingredient for life as we know it. But hold on, it's not all sunshine and rainbows. Proxima Centauri is a red dwarf, And red dwarfs are known troublemakers. They're hyperactive stars, constantly firing off powerful solar flares, intense bursts of radiation that can scorch a planet's atmosphere. Proxima B gets blasted with radiation hundreds of times stronger than what Earth experiences from our sun. If that planet doesn't have a strong magnetic shield or a thick atmosphere to protect it, those flares could literally strip away its air, leaving the surface exposed and hostile to life. So yes, Proxima B is close and in the right zone, but whether it's actually habitable is a whole different question, one scientists are racing to answer.
Even with all its challenges, Proxima B still holds a special place in the world of science. Why? Because it's right next door, cosmically speaking. At just 4.2 light-years away, it's one of the closest exoplanets we've ever discovered. And that makes it our best shot at really getting to know a planet beyond our solar system. And the more we look, the more we learn. We've confirmed it's not a gas giant, but a rocky planet, solid ground, like Earth. We know its size, how far it orbits from its star, and now, thanks to the incredible James Webb Space Telescope, we're starting to get a clearer picture of what it actually looks like. Sure, Proxima B lives in a rough part of town, blasted with radiation from its active red dwarf star, but it's still the most promising candidate we've got for another Earth-like world nearby. It's not perfect, but it's real, it's close, and most importantly, it's possible. So how did we manage to see it? That's where the James Webb Space Telescope comes into play. This isn't your average telescope, it's a game changer. Launched in 2021, Webb was built to go beyond what any telescope has ever done before. Yes, it's great at spotting galaxies billions of light years away and peeking at stars being born in far-off nebulae, but it's also uniquely equipped to study exoplanets like Proxima B, ones right in our interstellar backyard. Unlike most telescopes that collect visible light, Webb uses infrared vision. That means it doesn't just see what we see, it picks up heat, and that gives it the power to cut through clouds of dust, gas, and even the overwhelming glare of nearby stars that usually hide planets from view. Capturing an image of Proxima B hiding in the bright light of Proxima Centauri isn't easy. It takes more than just pointing a lens and snapping a photo. Scientists relied on two of Webb's most powerful instruments, NIRCam and MIRI. These tools didn't just take one picture, they gathered light pixel by pixel over weeks of careful observation. And from that data, they slowly pulled together the most detailed view of Proxima B we've ever had. This isn't just another blurry point of light. This is a world, a place with its own surface, its own sky, and maybe, just maybe, the right conditions for life. And we're finally starting to see it for what it really is.
The James Webb Space Telescope doesn't just take quick snapshots like a camera on Earth. Instead, it gathers faint traces of light, tiny, almost imperceptible signals over days and even weeks. Imagine patiently waiting, pixel by pixel, collecting whispers of heat and light from across the void. Then, like assembling a cosmic puzzle, scientists stack all that data together, carefully removing the background noise to reveal something extraordinary. In this case, what they uncovered was the faint thermal glow of Proxima B, subtle heat signatures emerging from behind the overwhelming brightness of its star, Proxima Centauri. It's like trying to spot a firefly next to a lighthouse, but Webb pulled it off, and the result? A breakthrough. A real, visible contrast between the star and its planet. Enough detail to confirm that Proxima B isn't just some theoretical blip or an illusion caused by data. It's real, it's rocky, and it's physically there. But Webb didn't stop there. It went further. It measured how bright the planet appeared over time. It watched how heat was distributed across its surface, and it even tracked how that heat changed as the planet orbited its star. From this, scientists could deduce something incredible. Proxima B is probably tidally locked. That means one side always faces its sun, scorched in eternal daylight, while the other sits in endless, frigid darkness. Think about that. A world split between fire and ice. One side baked by constant radiation, the other trapped in a permanent, frigid night. That detail alone reshapes how we imagine what life or survival might look like on such a planet. And all of this? It simply wasn't possible a few years ago. We didn't have the tools. But Webb's advanced infrared tech is like going from a fuzzy webcam to ultra-high-definition night vision. We've gone from guessing Proxima B existed to actually seeing it as a world of its own. This isn't just about cool space photography. It's something much more powerful. It's a key to unlocking the mystery of other planets, a way to stop thinking of them as just numbers in a spreadsheet or dots in the sky. Webb is transforming them into real, tangible places. Planets with light and shadow, heat and cold, movement and shape. And that brings us to the big question. What exactly did the James Webb Telescope see when it focused on Proxima B? Well, it wasn't a pretty Instagram-style photo with colors and clouds. The image comes from invisible infrared light, heat radiation, not visual color. But what it revealed is far more exciting than any sunset snapshot, because behind that heat pattern is a world, a real place. And for the first time in human history, we're not just imagining what that place might be, we're seeing it.
Now, here's where things get really interesting. The raw data from the James Webb Space Telescope isn't something you can just look at and instantly understand. It's not a photo you'd hang on your wall. But when scientists process that data, they apply special color filters to help us see the invisible. The brighter spots, those show areas where it's warmer. Darker patches, cooler regions. And from that heat map, an entire story begins to unfold. First off, the surface of Proxima B looks rocky. That's huge. The way it reflects light suggests it's made of solid material, rock, dust, maybe even dirt. It doesn't behave like a gas giant, and is definitely not shrouded in thick cloud layers like Venus. This is the kind of surface you could, in theory, walk on. It's tangible. It's real. That alone sets it apart from many other exoplanets we've detected. Second, there's a striking temperature split across the planet. One side is clearly much hotter. That's likely the side that's permanently facing its star. The other half, cold, dark, locked in endless night. This happens because the planet is so close to its star, it's tidally locked, meaning the same side always faces the light while the other never sees it. That might sound harsh, and it is. But there's a silver lining. Right between those two extremes is a region scientists call the terminator line or the twilight zone. In that narrow band, temperatures might be more stable, possibly even just right for something like water or life to exist. Third, there's a tantalizing clue that Proxima B might have a thin atmosphere. Webb detected a delay in how heat escapes from the planet's surface. If it were a bare rock in space, heat would just radiate away quickly. But here, the warmth seems to linger a bit. That could be the result of an atmosphere, even a fragile one, holding on to that heat. And if that's true, it's a game changer. An atmosphere isn't just a protective blanket. It's the difference between a dead rock and a potentially habitable world. It's what allows weather, liquid water, and possibly even biology to exist. And finally, scientists are leaning in, asking what else could be hidden in that faint glow? Could we be seeing heat from volcanic activity, maybe even active lava flows, or something even more speculative? Tiny lights on the dark side, artificial light. Could it be cities, structures, signals? Webb is actually sensitive enough to detect a weak, unnatural glow if it's there. We're not saying there are aliens shining flashlights back at us, but we're finally at a point where our technology could notice if they did.
Right now, we don't have solid proof of volcanoes, lights, or even an atmosphere. But the fact that we can even ask those questions, that's a massive leap forward. What the James Webb Space Telescope gave us isn't just a blurry snapshot from deep space. It's the closest humanity has ever gotten to standing on a distant planet and looking around. The story hidden in the light. Now that we've finally seen Proxima B, scientists are going full detective mode, analyzing every single pixel of light to decode what kind of world this really is. First, the surface looks rocky. That might sound basic, but it's a big deal. It tells us this planet has solid ground, actual terrain. We're talking the potential for mountains, craters, maybe even ancient riverbeds. It's not a puffy gas giant like Jupiter, and it's not blanketed in thick, toxic clouds like Venus. It's solid. That alone makes it a standout. Second, the planet's brightness, specifically how it absorbs and reflects heat, reveals its texture. It doesn't reflect like ice or metal. Instead, it behaves like dry, dusty rock. That tells us it could be more like the surface of Mars or a sun-scorched desert here on Earth. That kind of surface could support features like ridges, rock plains, and possibly erosion patterns from long-lost water. Third, there's a subtle but intriguing hint of atmosphere.
It's not confirmed yet, but when scientists looked at how heat spreads across the planet's surface, something didn't add up. If Proxima B had no atmosphere, we'd expect heat to vanish the moment it reached the dark side, but instead, there seems to be a gentle gradient, heat that lingers just a little longer than expected. That might mean there's a thin layer of air, just enough to trap warmth and prevent wild temperature swings. And fourth, there might be signs of volcanic activity bubbling below the surface. Some areas in the thermal data appeared warmer than they should be. That could suggest internal heat rising up, maybe from an active core. If that's true, it's not just fascinating, it's vital. A hot core can fuel geothermal activity, drive magnetic fields, and even help hold an atmosphere in place over time. So, no, we haven't found aliens or streetlights glowing in the dark. Not yet. But we've moved from vague numbers and guesses to actually seeing the planet next door. Proxima B isn't just a theory anymore. It's a real place with real conditions that we're slowly uncovering piece by piece. And this is just the beginning.
We haven't found concrete proof yet. No glowing volcanoes or city lights flickering in the darkness. But the fact that we can even ask questions like that alone shows just how far we've come. This isn't just another blurry blob in space. This is the closest humanity has ever gotten to standing on the surface of a planet orbiting another star, Proxima B, and looking around with our own eyes, decoding the light. What Webb is telling us. Now that the James Webb Space Telescope has delivered the first real glimpse of Proxima B, scientists are diving deep into every bit of data, analyzing the light pixel by pixel, hunting for clues about what this alien world is really like. Clue number 1, it's rocky, really rocky. That may not sound like a big revelation, but it's huge. It means Proxima B isn't some swirling ball of gas like Jupiter or smothered under a thick toxic atmosphere like Venus. It's a planet with a solid surface, actual ground, possibly with mountains, canyons, or even the scars of ancient rivers. By looking at how the planet reflects and absorbs heat, Webb showed us something else. This surface isn't icy or metallic. It reflects heat like baked, dusty rock. Think Martian desert, dry, rugged, sun-blasted terrain. That gives us a picture of a harsh but potentially stable environment. Clue number 3, there might be an atmosphere, just barely. Webb picked up hints in the heat distribution across the planet. On a world with no atmosphere, temperatures should drop off dramatically on the dark side. But on Proxima B, heat lingers just a bit longer than expected. That suggests there could be a thin atmosphere holding in some warmth. Maybe not breathable, but enough to moderate extremes, enough to make life possible, if not comfortable. Clue number 4, the planet may still be geologically active. Some regions showed up warmer than they should be on the thermal map. That could be evidence of geothermal energy, heat from within, maybe volcanic hotspots.
Just like volcanoes on Earth breathe out gases that help renew our atmosphere, scientists think something similar might be happening on Proxima B. And every new piece of data we gather is like adding another puzzle piece to the picture. We still can't say for sure if this world is truly habitable, but we can say this: it's not just a dead rock floating in space. Proxima B is active, it's dynamic, and above all, it's full of mystery. Living in a rough neighborhood. Sure, Proxima B is sitting in the so-called habitable zone, the sweet spot where a planet gets just the right amount of energy to allow liquid water. But let's be clear, this planet lives in a dangerous part of the galaxy. First off, its host star, Proxima Centauri, is a red dwarf. That means it's small and cooler than our sun, but don't let that fool you. Red dwarfs are known for their temper. They can go from calm to chaos in a flash. They unleash sudden, violent solar flares, blasts of radiation that can last for hours or even days. And Proxima B? It gets hit with that radiation way more often than Earth ever does. Second, these flares don't just light up the skies. They could wreck the planet's chances of holding onto an atmosphere. Without a strong magnetic shield, like Earth's, the constant radiation could peel that atmosphere away bit by bit. And once that happens, any surface water would evaporate or freeze, leaving the planet barren. Third, there's a twist. Proxima B is tidally locked, meaning the same side always faces its star. One side is in permanent daylight, the other in endless night. But there's hope. There might be a narrow strip, the twilight zone, right where day meets night, that has just the right conditions. Temperatures there could be more balanced, and if there's even a thin atmosphere left, it might be enough to hold liquid water. It's a tight line to walk, but maybe, just maybe, life could find a way to survive there. Fourth, here's where things get really interesting. New computer model suggests that if Proxima B had something like Earth's ozone layer, a protective bubble of gas that blocks harmful ultraviolet radiation, then even with all those brutal flares, parts of the planet might still be safe. That ozone layer could act like a shield, protecting small regions from the worst of the radiation. It wouldn't make the whole planet safe, but it might create little pockets where life could hold on. So yeah, Proxima B is constantly being blasted by its star. It's not a peaceful neighborhood by any stretch, but somehow it's still hanging on. And that's what makes it so compelling, because in the heart of all that chaos, there might just be a place where life can exist.
But what if, despite all the flares, radiation, and darkness, Proxima B is still holding on, tucked into that narrow twilight zone, caught between eternal day and endless night? Maybe, just maybe, it's surviving, shielded, balancing on the edge of habitability, signs of the unseen. Here's where the story really takes a turn, from science to something that feels almost like science fiction. But the wild part, it's still grounded in real possibility. What if there's more happening on Proxima B than just rocks heating up and cooling off? Let's start with the basics. The James Webb Space Telescope, JWST, is so powerful it can do more than just take pictures. It can pick up faint glimmers of light that could be artificial. Think about that for a second. If there were a civilization living on Proxima B, one advanced enough to build cities or place giant mirrors in space, we might be able to see the glow of their technology. Wild, right? But here's how it works. First, if an intelligent species is out there, they might not want half their planet frozen in darkness. So imagine this. They install enormous orbital mirrors to bounce light from the day side over to the night side, kind of like a giant cosmic spotlight. That would make the entire planet more livable, reducing those harsh extremes between the scorching light and the deep freeze. It sounds far-fetched, sure, but not impossible. And JWST is sensitive enough to catch hints of something like that. Second, even if we haven't seen anything obviously artificial yet, Proxima B is now sitting at the top of the list for future SETI missions. If there's intelligent life anywhere close to Earth, this is one of the first places we're going to look and listen. Third, this isn't just about one planet anymore. It's about what we're now able to do as a species. For the first time in history, we're not just wondering if a planet could support life. We're wondering if someone could actually be living there. Not bacteria, not moss, but a civilization. And most incredible of all, we're now equipped to start finding answers. JWST isn't just a telescope, it's a key to unlock worlds we've only ever dreamed of, and to ask the biggest question of all: are we alone?
Our first real glimpse of another home. What we've just seen, this image of Proxima B, changes everything. This isn't just some dot on a star chart or a bunch of numbers in a research paper. This is a real place. Let that sink in. First off, Proxima B is the closest potentially habitable planet we've ever found, just over 4 light years away. That's practically in our cosmic backyard. And now we know it's rocky. We know it might have a thin atmosphere. We know its surface shows clear temperature contrasts, suggesting real dynamic conditions, not just a lifeless rock drifting in space. A world with texture, with weather, with possibilities. Second, Proxima B has become something more than a planet. It's a symbol, a template for how we'll study alien worlds going forward. If we can get this kind of detailed view of Proxima B, imagine what's next. The 7 Earth-sized planets around TRAPPIST-1, or the worlds circling stars like Tau Ceti. This is just the beginning. Third, this discovery stirs up something primal, our desire to explore. Let's be honest, Proxima B feels reachable. Sure, with today's spacecraft, it would take about 75,000
5,000 years to get there, but that's today. Cutting-edge concepts like solar sails, pushed by beams of light, could get us there in just 20 years. That's not science fiction anymore. That's breakthrough starshot, a real project working on making it happen. Fourth, this image is a checkpoint in human history. We used to ask, are there planets beyond our solar system? Now we ask, what are they made of? Could we live there? Is someone already living there? Proxima B isn't just a planet anymore. It's our first concrete step toward another world, a spark of hope, a goal, and maybe, just maybe, the first real shot we have it finding a second home. So, now the biggest question of all. If Proxima B is another Earth, who or what might already be there? Let your mind wander, dream a little, because this is just the beginning. And if you're as captivated by this journey as we are, hit that subscribe button and join us as we chase the greatest mystery of all. The universe is waking up. Let's go see who's out there.